Hey guys, we got a trouble call for a transfer pump that keeps faulting. Operator doesn't know why it's faulting and wasn't able to see any faults displayed. So we'll head over and see what we can figure out. All right, see you there. They show up,
No power.
everything's off, nothing's running. Then they power everything back up and they say
No faults.
there's no faults on the display. So what we'll do, we'll go into options, or actually no, we'll go menu. There it is. And then it's probably under diagnostics, fault and event log, faults,
Earth leak.
1980, earth leakage yesterday. Looks like the internal clock is a little off. But we had an earth leakage yesterday.
What does that mean?
I'm pretty sure earth leakage is like a ground fault. Those are all the times it's shut off. Details. It was running, fully loaded. Yep, fully loaded, and then it had an earth leakage. This morning, yesterday. And that's it. No other faults or events. So earth leakage. Let's look that up in the ACS 580 manual and see what it says. In motor or motor cables by measuring the insulation. Try running the motor in scalar mode if allowed. If no earth can be detected, contact your local ABB. Earth fault. So basically it's saying there's an earth fault somewhere. So we'll get the megger and we'll go down to the disconnect and we'll meg just the motor and the cables down there and see what it shows us as far as resistance levels. Do you know what that megger does? It'll charge up a wire and it'll measure ohms. So it's basically an overpowered continuity checker. So what you're going to do, you're going to stand over here. You're going to put the megger in, you're going to take this probe and put it over onto insulation. Good. All the way in. Then you're going to clip your black probe onto that ground lug. Nice and secure. Yeah, as long as it doesn't fall off, we're not going anywhere. Then you're going to take your red one and you're going to click it onto phase A. Just anywhere on, so this whole thing is continuous. Yeah, so you can clip there and that's phase A. So this motor runs, bring it out a little bit. Yep, this motor runs at 480 volts. So we can safely charge it up for a short period of time with 1000 volts DC. So we're going to put it on 1000 volts and then we're going to hold down the test button. That's a good reading. You can release the test button. We'll say greater than 1.5 gigohm. 1.7, 1,777,000,000 ohms. So do that on the line 2 now. And maybe you gotta come like this, you know. Yeah, there you go. Go ahead. It should be the same thing, because the other end of this wire is this wire is this wire. They're all connected. Good. And then do line 3. Good. Okay, now you're going to switch this red over to the ohms. And then you're going to put your clip on 2, red on 2, and black on 1. And we're checking the windings resistance now. But we're not going to put 1000 volts through. We're just going to put it in old-fashioned continuity check. And just hold down test. Good, 0.11. And then do from 1 to 3. Very good. 0.1, good. And 2 to 3. Good. That's a healthy motor, in my opinion. I don't see a ground fault there. Once you're over a gig ohms, that's very high reading.
Which one would be a gig? That or?
Well, this isn't a gig, and this is a fraction of 1 ohm. So this is a 17th of 1 ohm. Because there's almost no resistance between these because they're all connected in the windings in the motor. Now, I did just have this problem with an intermittent ground fault on pump 2, and it was very frustrating to find. But the fact that it's not here now makes me want to check the feeder. So we just checked the cables from here to the motor and the motor itself. But what we haven't checked is from here back to the soft starter, or excuse me, the VFD. Now, we can't just go pumping 1,000 volts onto that because you can mess up your VFD because of how it's connected. So if we're going to do that, we need to go over there and look at how it's connected and possibly disconnect it. So let's leave this open and we'll remember to come and shut it and turn it back on. But for now, we'll isolate the motor from that. So when we do this next test, we're only looking at this conduit run and the MCC. Cool? All right, let's go. Exact same thing we did down in the hole. Go ahead and put your red lead onto insulation. Then you're going to put your black on a good ground reference. Nope. That's a good ground reference. Then you're going to clip onto him. Very good. And then you're going to put it on 1,000 volts. And you're going to lift that thing up so I can see the reading really good. Yep, there you go. Now hold down test. Oh, cycle it to off and then back to 1,000. It needs to turn on. There you go. Nothing? Still not on?
Yeah.
Let's give it a little whack. You're good. It's not the leads. It's him. What'd you do to him?
I just threw him down the staircase and...
There we go. Okay, so now he's on 1,000. Go ahead and hold it down. Good. Greater than 3 gig ohm. Go ahead and move on to phase B. Same thing, 1,000 volts. Yep, good. 3 gig ohm and phase C. Great. To me, that means that those cables between here and the disconnect are healthy, so you can take your probes off and put the Megger away for now. Cool, you can hop out. I'm going to put it all back together. So yeah, that rules that out. Okay, so we checked between the disconnect and the motor and between the disconnect and the drive. Now I just want to be extra paranoid and look inside the pecker head. So don't drop my tools in that lube oil and then go ahead and take those 4 screws off. I'll take everything you're not going to use. It's either 9 or half, I can't remember. So now, right there, see that? That's a little sus. We had a very similar problem on this one where the splice was bumping into the head of the thing. Pick up the pecker head cover. Right there. Right there. Look at that. Do you see that? Right there. It almost looks like a little arc. Okay, you could set that back down. Honestly, yep, I can even see That's metal. I think. Yeah. Yeah, so these splices were just not done very well. So there's our problem. We just need to get this taped up a little more to insulate it and kind of pull it in a little bit, maybe with some zip ties or something, just to keep it from rubbing on the inside of the cover. But there you go. Easy fix for a simple problem. Let's look at this one. Make sure they're not touching. No, they look good. Yeah, it's totally just right there. It's almost the identical problem as the other one. Okay, that'll mean an identical solution. So we can put him there. We can't forget him when we put it all back. All right. Yeah, can you push back on that? Perfect, just right there. Okay, let go. Perfect. Yeah, he's good. Perfect. See you on the next one. That's it.